The next program is program number 11. Develop a program to implement k-means clustering model for the given value of k, where k is the number of clusters. So we basically try to model k-means clustering. So this is the program. And there is a short notes about this program. What is clustering? That is grouping of your data. So k-means clustering is the working of your k-means clustering is this. These are the steps followed in k-means clustering. It is an unsupervised algorithm. So it deals with unlabeled data. So choose the number of k clusters, the value of your k. Then you need to start with k centroids by putting them at the random place and checking every point with respect to the closest centroid. I'll just show here. For example, consider that this is the set of the data 170, 60, 160, 55, 180, 75, 150, 50, 175, 65, 180, 85. So how does basically the clustering algorithm works is initially randomly it will choose two groups of the data. So it can be randomly chosen. Here we are choosing 1 and 2 data, 170 and 60, 160, 55. Now these serves as the centroids as well. Now we check with the third row as these two form different sets of the data. So the first set and the second set forms two different sets here. So this is the initial set of the clusters. Now with respect to each and every row 180, 75, we will check distance. The distance which we follow throughout is Euclidean distance. So it is x2 minus x1 whole square plus y2 minus y1 whole square under root. So now considering the third point 180, 75, using Euclidean distance, we check 180 minus 170 whole square plus 75 minus 60 whole square under root. So that you get some value. Similarly, 180 minus 160 whole square plus 75 minus 55 whole square under root. That gives the one value. So among this, if row 3 is closest to 1, that is the minimum value of the distance, then it means it is closest. So it may be either close to set 1 or set 2. So based upon the distance, for example, the calculation here is row 3 to row 1 is 18.02 and row 3 to row 2 is 28.8. So obviously row 3 belongs to the set number 1. So 1, 3 forms one cluster and 2 is as it is. So now next we will take 150 and 50 and again check with this. But meanwhile, because 3 has been added to 1, we need to calculate the centroid. So randomly we have chosen initially these are the centroids, but once another point 180, 75 is added to this particular set, as I said, 3 belongs to this first cluster now. So once you are placing the cluster 3 to this particular cluster 1, then you need to calculate the new centroid value, right? So x1 plus x2 by 2, y1 plus y2 by 2. So that forms a new cluster. Now 1, 2, 1, 3, sorry, and 2 stands as it is because 2 we kept like that. But this third row we have added to the first row. So the centroid value changes. So at every point of time, we need to calculate the distance and keep updating the centroid. Finally, what does this k-means clustering results is out of this 1, 2, 3, 4, 5, 6, now randomly we have chosen 2 clusters. So which points belongs to the cluster 1 and which points belongs to the cluster 2? That is what k-means clustering does. Right here 1, 3, 5, 6 belongs to one cluster and 2, 4 belongs to the next cluster. We have chosen the k value as that is randomly we have chosen the first set as well as the second row as the values here. So k is equal to 2. In case I am writing k is equal to 3, the values also keeps changing. So as said, the program is implementing k-means clustering for a given value of k. So this time we take the iris data. So this is how your iris data looks. You just go to your file iris.csv. So iris.csv has these as the input variables: sepal length, sepal width, petal length, and petal width, and species. So as usual, species usually is considered as the output variable, and all the other things are considered to be the input variables. now. So data is equal to read underscore CSV of iris.csv file. Then we will be printing data.head value. That is the first 5 rows will be retrieved here. So these are the column names as it is. Length, width, petal width, and species. So the first 5 rows have been retrieved here. The CSV file we are using is iris.csv. Now data.info, usually quick summary of the data is given with your info function. So it just describes the structure of the each and every column value. That is not null and float 64, or if it is an object and so on. Now next describe. Describe usually gives the statistical information, that is standard, minimum value, mean value, right? 25 percentile, that is 25 percentile of the data, 50 percentile, 75 percentile, maximum value, and so on, count and so on. So this all comes under the pre-processing of the data. Just I am retrieving the data. Next is to know whether there are any NaN values, null values in the data set. So since we got length, width, and species to be 0, that means that there are no null values existing in this particular data set. But if there are null values existing, then we need to replace the values, like with using your fill NA. We need to basically replace the values, and then we need to consider the data. Since if there are any values like NaN values and all, you can't feed that to the machine learning algorithm. Right. Next, this is only to know about your scatter plot. So this is how the data petal length and petal width is distributed. Right. So since it is an unsupervised algorithm, we need only the input variable. Right. Unlike the other algorithms which we have seen, we basically take your X as well as Y value. But since it is an unsupervised algorithm, you don't need to consider the output variable. Right. Our whole point is to group the variables, cluster the values available. So we basically choose only X here. We need only input variables here. So this is the input variables, 150 rows across 4 columns. Then we are selecting all the variables, sepal length, width, petal length, and petal width into your X, and species into your Y. This is general, like not only using your ilog 2, 3 or 4, we can usually directly assign these column values also, and we can store that in your X and Y variables respectively, and this is how it results. So this is general information. Now coming back to building the model. Now this is our major k-means algorithm. So k-means algorithm, the major parameters are n clusters, that is your k value. So here I said like we have assumed 2 values. So we started with k is equal to 2. So now the other set of the data will either belong to 1 or it belongs to 2. If I take k is equal to 3, there is another set of the variable. Then I'll 1, 2, 3. If I consider it as 3 clusters, then these 4, 5, 6 either fall in with 1 or 2 or 3, and right, similarly 5, similarly 6 also. So this is the k value. And random state, we have seen from the wherever we have seen the train underscore split, we have seen the random state value. Right, this will give the consistent data for each and every run instead of giving the random values. So now we are fitting the data with this particular X value, right? So X value is this one. So this is general information to print, and still we can retrieve the values with the column names as well. So we have used k-means, import your k-means function from sklearn this time. Now k-means function you are applying where you are considering 2 parameters. One is n underscore clusters, which is your k value in your k-means algorithm, and the random state to get the consistent data for each and every run. Now we are fitting this particular data. Now, as usual, we can even split the data with your X, Y, and you can predict the values also. So Y underscore predict is equal to predict of X underscore test. That is, we are testing with your X underscore test value and we are predicting. So predicting the values will be 1, 0, 2. Right. Then the major coefficients which you will be displaying for your k-means algorithm is model.labels as well as your centroids at every point of time. Right, model.labels, that is the input, that is your clusters, and then the centroid of the clusters. Like for example, these are your clusters 1, 2, 3, and so on. Now wherever you are calculating your centroid value like this, x plus y by 2 and y1 plus y by 2 by 2. Like this, the calculation of the centroids are retrieved using model.labels underscore, which represents one coefficient, and it will display the clusters. And the next one, model.clusters underscore centers, will usually display the centroid values. So considering your k is equal to the k value we have considered as 3 here. So assuming 3 clusters, so that is the reason you will be getting your model underscore labels also categorized into 0, 1, 2. And other, when the k-means algorithm is working, as usual, the two things play a major role. One thing is to calculate the Euclidean distance, that is measuring the distance for each and every point with respect to the other point. And the next one is changing the centroid at every point wherever a cluster has some change in that. So those two are retrieved using model.labels underscore, and the next one is model.cluster underscore centers. So this is how the centroid information is displayed, and this is how the cluster information is displayed. Right. This is your k-means algorithm. So we don't require your y value. So if y value is required, it is your supervised algorithm. Right. So the next one is develop a program to implement hierarchy clustering model for the given value of n, where n is the number of clusters. So this is our program here. Right. So this is also a clustering algorithm, and it is unsupervised algorithm. So we, instead of taking any CSV file, we have taken directly your x values and y values here, and we have plotted a scatter plot here. This is how the values are spread over here. Now, just knowing about the working of your hierarchical clustering, there are basically two types of hierarchical clustering, agglomerative as well as divisive. So it depends upon the approach. See, finally, the primary aim of this algorithm is also clustering, that is grouping the data. Right. Now, if you generally check here, this is how the grouping works. Create each data point, right? That is, it will basically consider each data point as a single cluster. So consider these as your number of the clusters. Then we take two closest data points and merge them into one, and we create n-1 clusters. Further, this is how it is grouped. And then we form basically one whole cluster out of this. So for example, consider this is our data 18, 22, 25, 42, 27, 43. This is how usually the algorithm works here. So we will construct a distance matrix, that is for each and every point. For example, 18 to 18, the distance is 0. The distance calculation is again the Euclidean distance itself. 18 to 22, the value is 4, 18 to 25, 7, and so on. So these diagonal elements will always be 0, and this exactly will be the mirror image of this one. This whole diagonal points above the diagonal and below the diagonal are mirror image points. Now, we'll consider one minimum distance point from this one, and we will start grouping the data. So for example, 42, 43. The minimum distance data is considered, and the values are combined to form one cluster. Similarly, once 42, 43 is merged like this, we will consider the next least distance points, and we keep merging one value over the other value and form one whole cluster over here. Right now, the distance, the cluster is 25, 27, 22, 8. Right. So on the whole, a whole cluster you basically form out of your hierarchical cluster. So this is like your hierarchical cluster. The name itself specifies the either top down or bottom up hierarchy over here. So this is a simple algorithm where at every point we'll calculate the distance considering the minimum distance. For example, here the minimum distance is 1 here, for which elements it is 42 and 43. So 42, 43 forms one cluster. Then you can remove the value, one value over here, one row over here, and check with the next least distance 2. For example, if 2 is there, 25, 27 can form one cluster, and you can remove that particular this particular column also. That is that particular data. This one you can basically remove. And then again, you will consider the next one, which is 3, 25 as well as 22. So again, group that. There is no 25 as such because your 25 is already grouped with 27. So that forms another cluster. So we keep merging them and we form one single cluster out of that. That is what the diagram over here shows. It is one cluster you will form. Now out of that, you draw a dendrogram like this. So these are all the data points over here. And you have combined 42, 43 first, then 25, 27, then 22 with 25, 27, then 18 with this whole data, and then the whole data to your 42, 43, and you're forming one cluster. So this is your dendrogram representation. Now going back to our program, first we have taken the similar points, x, y points, like how we have shown here. X, y points we basically take here, like this. Right. Now, we have scattered, we have a scatter plot over here where the data is spread over here like this. Now, right, we will be importing two packages here, linkage as well as dendrogram. We will use the zip of x, y. What does this do is, so for this 4, see, usually 4, 5, 10, 4, 3, 11, 6, 14, 6, 10, 12 is one set of the data, one dimension of the data, and y is another dimension of the data. But now to make your 4, 21 as one point, 5, 19 as one point, 10, 24 as one more point, 4, 17 as point, 3, 16, and so on, we need to zip the data. Zip the data into your x, y such that this data x as well as x1, y1, x2, y2, x3, y3, x4, y4, and so on will form a data. So that is given with your data here. Now, right. Now, the next one we use is the linkage function here. The first one, zip the data. So we'll basically combine the data x1, y1, x2, y2, x3, y3, and so on. And then we are going to use the linkage function. So this linkage function is an essential prerequisite for a hierarchical clustering analysis. So what does this do? This linkage function, its value is a measure of the distance between the two groups of the objects. That is, between two clusters, it basically measures the value. Right? So there are single linkage clustering and so on with respect to this linkage methods as well. Right. So this basically performs the agglomerative clustering, or if at all we go with your divisive clustering also, it is the same. So the distance measurement every time is done with your Euclidean distance. So wherever you want, you can basically use the distance measure as a Euclidean distance over here. Now we call your dendrogram for this particular linked data. So we are zipping the data where we are forming your x1, y1, and so on. And then the prerequisite of hierarchical cluster analysis linkage we are using so that it measures the distance between the two group of the objects directly. And the distance type it uses is Euclidean distance. And then for this linked data, we are forming a dendrogram. Now you can see here, these are the values, right? How many values are there here? There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 values. So those values are grouped from 0 to 9. Now, right, we are using only linkage function over here. And you can see the output as your dendrogram over here. So that data, that is 0th data is 4, 21. First data is 5, 19, which is represented here. So this is our 10 sets of the data, 10 set of the data here. So wherever you are having 0, that means your 4, 21. Where you can see your 1, it is 5, 19, and so on. So this is how the data is combined. So 0 and 1 is first combined, then 7th data is combined to this, then 3 comma 4 data is combined, and this whole 3 comma 4 and this 0 1 comma 7 is now grouped into one more data, 2 comma 5 6 8 9, and this whole thing is grouped into another data, like how we have shown here for this set of the data, right? Dendrogram representation, which all groups you have basically combined. So that linkage is done, and this is the dendrogram representation of the data. Then comes our agglomerative clustering, which is the actual clustering algorithm. So we usually take the number of clusters as a parameters, and then affinity, usually Euclidean distance, the calculation, and the linkage is what here. Now we usually, that is, I am calling the agglomerative clustering. It is in your sklearn dot cluster. And then the labels, you are giving one variable called H labels, where you will use your fit underscore predict of the data. So what is data here? Data is our x comma y values. So we are going to use your agglomerative clustering. So this is equals to H underscore CLU. So using your H underscore CLU, you will fit and predict this particular data and print your H labels. And then as usual, we can basically go with scattering the values as well. So these are the H labels 0, 0, 1, 0, 0, 1, 1. So there are how many clusters we have used? 2 clusters. So 0 is one cluster and 1 is another cluster. So if you just keep n underscore clusters is equal to 3, accordingly this also will change. So this is the scatter plot representation of x comma y over here. Now we can, if you just click on H underscore CLU dot fit of data, that is whatever we have done here, it directly gives you the agglomerative cluster. And as usual, the labels underscore is a coefficient which gives you the cluster data. And here to measure the score, we basically use Shillett score, like your accuracy score in the other algorithms. We use Shillett score. So Shillett score will be in the range of minus values, 0 values, as well as your plus 1 values. All right. So Shillett score is calculated using the mean intra-cluster distance and the mean nearest cluster distance in the clustering terms. And the best value is 1 and the worst value is minus 1 as usual. Now here we got 0.56. So the values near 0 indicate overlapping clusters over here. So the negative values generally indicate that sample has been assigned to the wrong cluster. If at all I am getting the negative value and all. Now we got the Shillett score as 0.56. Usually the values can be in your negative values as well as your positive values. So as usual, if at all I get the Shillett score as 1, that means that it is best value. And if at all I get the values near 0 like this, it indicates there are some clusters which are overlapping. And negative values usually indicate that a sample has been assigned to the wrong cluster, right? So that is how you basically measure your clustering algorithms.